good morning, good evening, good afternoon, everybody. We have a very diverse geography visiting us today, so thank you all for coming. It's great. I'm Susan Oslen, and I am the co-producer of AW Nite LA. And Ray, would you like to introduce yourself?
Hey everyone, you might know me. Susan and I have been doing this for this is our third year of this. This is our fourth event this year, I think. COVID has not stopped us from keeping these events going, and so Susan's been really passionate about kind of UX and kind of the different ways that you engage with that, with all kinds of interesting sort of devices and sensors, and she's put together this incredible panel of experts to explore that.
Yeah, we have. So there's just a few things, housekeeping, that AWE wants us to take care of so that you get full benefit from the organization. I don't know if you guys are aware of the number of AWE nights that are around the world, that people are having events monthly by monthly. Japan is actually the biggest group of anyone. But actually, LA was one of the very first, I think, after New York and San Francisco. So we've been around for a long time, but everyone's doing great content. The last count I had was 15, but it's obviously more than 15 now. I'm not sure what the count is. But keep your eye open for events from all different cities, because there's always really great content happening around the world. As many of you probably know, that the big live event is happening in November, live in Santa Clara, but they're also planning for people who can't be live, so it's a hybrid event. Ray, do you want to say anything about it? You want to announce the discount code?
I don't happen to know it offhand, but I'm excited for this event to finally be back in person. I think we've been spending a lot of time doing these Zoom events, and it's exciting to see that these physical events are starting to trickle back into existence.
These are the channels where you can find AWE Global. There's a YouTube channel that has a lot of sessions from past AWEs, so that's a great place to go for content. There's a newsletter, and then unfortunately, the social media tags are not consistent, so you might have to do a little digging to find the different Twitter, LinkedIn, Facebook page, and the Instagram is fairly new in the past year or so. AWE Nite LA has a Twitter account and a Facebook group.
Yeah, I found the discount code as well. It's in caps, AWE Nite LA, the number 20, the letter D. So there you go.
Cool. Thank you. And just to let you know, there's a bunch of other stuff that AWE is doing. They are creating workshops and classes now. And so I did this WebAR workshop. I really enjoyed it. There's one on collaboration tools that's led by Charlie Fink. And then they also have one for Quest development and HoloLens development, which I haven't done, so I can't tell you about those, but I'm sure they're good. Ori obviously has great connections and, gets the top people to teach these courses. So that's it for the AWE stuff. So why don't we get started with the introduction of our amazing speakers. I'm going to start with Dave Birnbaum. Dave and I know each other from another project that we're doing that centers on cataloging and describing interaction patterns across VR. And so I'm really excited for him to talk about haptics tonight and talking about designing for haptics. So Dave, do you want to give yourself a little introduction and let us know a little bit about your work?
Sure. Should we introduce everyone first, and then I'll show the...
Yeah, that's probably a better idea. So you just want to give a quick...
Yeah, sure. Yeah, so hey,
seconds.
I'm Dave. I've been working in haptics pretty much my whole career. Haptics is technology for the sense of touch. And I come at it from a UX design and innovation perspective. And so most of my work centers on utilizing the sense of touch for new interactions.
Cool.
And I'll pass it to Ramses.
Hey everyone, my name is Dr. Ramses Alcaide. I am the CEO of Neurable. We make brain-computer interfaces. That is basically a fancy way of saying that we develop technology that enables us to record your brain activity and then allow you to use it to either control devices or understand yourself better. And so today I'm going to be talking about this mainly from the development end of how brain-computer interfaces can start to be used in consumer applications for different interactions, etc. So with that, I'll pass things off to Simi.
Hey everyone, my name is Simi. I'm currently lead product manager at Magnopus. Magnopus is an LA-based experience company that is forging art, design, and technology to create rich experiences across the digital and physical worlds in ways that people haven't yet experienced. My background is actually in architecture, and it was my master's in architecture from UCLA that actually opened the doors to the XR industry. It was based on the intersection of design and technology, and that's really what allowed me to pursue product roles building XR solutions over the years. So today I'd like to talk to you guys about smart spaces. I'm going to pass it on to Elias.
Thank you, Simi. Elias Stefan from HP, and I am from the Bay Area. I live in the Bay Area, California. I've been with HP a long time, 24 years. Today, I'm going to talk about a brand new solution from HP called HP Omnicept. This is for the first time HP brings not just a headset, we bring also an SDK into the marketplace that has bioanalytic sensors as well. So in the last year and a half, couple of years, I've been focusing on designing a program to go to market and also building an ecosystem with ISVs, independent software vendors across the world around Omnicept ecosystem. So I'll show you what we have announced last week.
Very excited. I've been waiting for that product for a little while now. So, Elias, why don't you get started and tell us a little bit about the Omnicept?
Yeah, I mean, I could share my slides quickly, okay, and then show you what we have here. So again, this HP Omnicept solution was announced, officially available for customers to buy and order last April 30th. A week and a half ago, almost, right? So it's called a solution because we're bringing, as I said earlier, the headset itself, and I'll show you what it's all about. And also we're building around it an ecosystem with ISVs with our SDK that I'll talk a little bit about as well. So I'm gonna go quicker than usual because I have limited time. I want others to talk. As an HP strategy in virtual reality, VR, we've introduced last year a product called Reverb G2, and it's been shipping since last October. And that product is doing absolutely phenomenal in the industry. And this can focus on consumer and also businesses, no sensories, just high resolution lenses, and a great product for gaming as well. On the right-hand side, focus on developers and also on enterprise accounts. We started shipping April 30th. So on the left-hand side, the brand new product is called HP Reverb G2 Omnicept Edition. We think it's the most intelligent VR headset by far, and you'll see why. And then in the middle, where our IP is the SDK, software developer kit, that our HP labs, when you say HP labs at HP, the people there are either PhDs, scientists, psychologists, so high-end intellectual people working on projects, not for today, also for the future. So this SDK has been in the making for the last 2 years. And we've tested the SDK across the globe in 4 continents. Basically, it's a piece of software that has machine learning and artificial intelligence, taking all the sensories, which I'm going to introduce you to from the headset, and making sense. For the first time, HP will introduce something unique in the industry called cognitive load insight, and I'll talk about that. Now, all of this is not going to mean anything to anybody unless we partner with independent software vendors that are going to create and innovate across that technology. Remember, HP is a technology company. We bring the latest hardware, but also this time we're bringing an SDK software product that is also going to change the way we look at bioanalytics, sensory, and then cognitive load, And then we're going to introduce you to a new concept called expressions and also emotions as well. So if you just follow the sequence, you'll see where this is going in the future as well. Now, quick video that will excite you. It has sound also in it. I love this video. It has nice quality sound, and you'll see what's in the headset itself. Here we go. Very cool. This video is also on YouTube. If you Google HP Reverb G2 Omnicept edition, you'll get that as well. So let's talk about the product itself, and then we'll dive quickly into an SDK, and I'll pass it back to you, Susan, to introduce the next speaker. We have eye tracking. We partnered with Toby as a technology partner. So inside eye tracking, you'll also get pupillometry, which is the eye dilation as well. So we're not just looking at your eyes where they're looking, we're also looking at your pupil as well, the dilation of the pupil. We also support foveated rendering. For those who are developers, you probably understand foveated rendering, which basically a technology gonna help the computer that is driving this headset. By the way, this is a tethered solution. It is connected to a workstation style with a good GPU, and that GPU with foveated rendering is not going to work at 100% full time. It's going to work less than that, maybe 50%, leaving the other processing power to do something else. That's what foveated rendering. And if you Google foveated rendering or go to Tobii, TOBII.com, you're going to see a lot of examples on that and a lot of videos. We added a PPG sensor on the forehead. When you put the goggles on, the sensor for the heart rate is inside touching your forehead. And then also, in addition to the 4 cameras in the headset, you see 2 of them looking like eyes looking at you, 2 on the sides, you don't see that well. And then we added this plastic rectangle at the bottom. It's a face camera. It's an HP camera capable of 3D images, looking at the bottom half of your face. And it's capable of, as I said, 3D images. So imagine the goggles on your face with a 3D camera looking at the bottom half. We're going to actually capture exactly what you look like. Now, what am I going to do with this? We're going to talk about something called expressions, right? Facial expressions that are going to bring into collaboration avatars that are going to look like you and I, real ones. On the right and left, you see speakers that are not touching your ears, like my headset here. It's making me sweaty or hot. These speakers are capable of spatial audio as well from HP, right? And if you've never experienced spatial audio, you should. It's a completely different audio experience. On the right and left as well, your enhanced controllers and a cable that goes to the PC itself, okay? So that is HP Reverb G2 Omnicept Edition, available to order on hp.com or resellers selling it across the world in 68 countries. Okay, so I'm not going to go through all of this, but again, eye tracking, pupillometry, eye dilation, foveated rendering. We believe in training. These are key when you develop VR applications with those technologies and so on and so forth. Similar to the face camera I talked about for expressions, and also last but not least, for healthcare and wellness. You're going to see heart rate is going to play a big role in applications as well. So to sum it up, eye tracking, pupillometry, heart rate, face camera, and we added for a perfect fit, a ratcheting headband at the top on the left. If you can see my mouse here, you just put the headset on your head and then play with the dial in the back for a perfect fit. And we kept the same resolution as a Reverb G2, which is 2160 per eye, okay? I'm gonna speed up, Susan, so just maybe I can see you, your video, just tell me 2 minutes, 3 minutes, I can see that. So you'll be the time police. So the SDK, this is where all the secret sauce and IP for machine learning and artificial intelligence. So another quick video, and then I'll dive into cognitive load and give you a view to the future on 2 new technologies that are also coming out from HP.
Introducing HP Omnicept, an intelligent XR platform that completely changes the dynamic of how humans interact with technology. Sensors in the headset monitor muscle movement, heart rate, pupil size, and gaze to capture the levels of brain power exerted. Now, users' natural responses drive their experiences in the moment. By combining sensor data with machine learning, software developers get real-time insights to tailor XR experiences for faster and better outcomes. Across industries, HP Omnicept is powering advanced XR solutions that can adapt to each user. Redefining how we train, improve well-being, create, and collaborate. HP Omnicept-powered apps help ensure the capture and transfer of data comply with GDPR and keep user data confidential. Groundbreaking hardware meets transformative software. This is HP Omnicept, a revolution in XR.
Another cool video. So again, the sensory from the headset, all the ones I talked about, are going to be captured by our SDK inference engine, right? And then for the first time, we're going to bring to the market cognitive load insight, which is basically a powerful predictor of those 3 rectangles you see in front of you here. Number 1, brain capacity, amount of working memory consumed while a person is undergoing an experience in VR. Second one is performance, indicator of user engagement based on amount of brain memory towards that VR task that you put them in, under. And then the last but not least is how well the learner knows and understand the content. So that's going to give you an example. I'll give you an example and we'll go from there. If you're training a pilot to fly a plane, the trainer is going to see the cognitive load of that person being trained, and he or she will have an indicator between 0 to 100, and based on all the sensory coming from the headset, whether it's heart rate, pupil dilation, and eye gaze, eye tracking, all of that is going to go into the analytics and the inference engine and give you an indication. Are they close to the 0? Are they in the middle? Are they overwhelmed, like maybe at 100%? So that gives you an idea on what needs to be done next in order to correct. Let's say you introduce an engine failure or fire in the engine. How is that pilot is going to react to it or adjust it, and so on and so forth. So that's how you determine expertise, performance, and also brain capacity in order to get to those 3 things: how much brain power is being used, and how does the user perform under stress, and how quickly our decisions are made. So that is our first insight, and we're going to build on that technology because of the sensories in the headset coming through this SDK. And then we're going to also introduce in the near future expression because of the face camera I talked about and the 4 cameras built into the headset itself. And I think the most interesting one is going to be emotion. We're going to also look at, are you smiling? Are you frowning? Are you happy? Are you sad? How your muscle movement is going on, right? We're going to track muscle movement. Are you sweating? Are you not sweating? So I threw at you a lot of technology, right? But HP is going to present this in a very simple way because of our AI and machine learning SDK for developers, creators to invent and create the most exciting VR or XR applications in the marketplace. Now, we sell that SDK to enterprise who have developers. We also give it to developers free of charge until they start making money, and then we go into a revenue share model. We give it to academia for free, for nonprofit. And if you want just the sensory, It's a free of charge SDK. But if you start looking at sensory plus cognitive load, spatial audio, you'll move in the ranking scale of payment for the SDK. Okay, and if somebody is asking, I don't see any chat questions. If somebody is asking, the price of the headset is $1,249 list US dollars. I know we have international people here, so I have to say US dollars, right? So that's all I have. And this is,
awesome.
yeah, thank you very much.
Thank you so much, Elias. And so while we're talking about biofeedback, why don't we move on to Ramses and let him talk about the way he's using sensors to create that feedback loop.
Yeah, absolutely. Absolutely. So I'm just going to share my screen real quick. So I'm primarily here to really kind of show a little bit about what we've been working on at Neurable. It has been an incredibly long journey. And to really understand Neurable itself, we really have to understand a personal journey of myself. So the story of Neurable really starts when I was 8 years old. My uncle got into a trucking accident and lost both his legs. And growing up, I saw him struggle through a lot of the unnaturalness of his prosthetics. And it really motivated me toward creating what we at Neurable called a world without limitations. And what this means is that we want to create a world where people with and without any type of impairments can equally participate in the world. So I went to the University of Washington and I studied control systems there and machine learning for prosthetic control. And then I went to the University of Michigan for my PhD in neuroscience. And after about 5 years in my PhD, I developed a signal processing pipeline that helped us amplify brain signals significantly higher than anything in the market. And that's really where Neurable was born itself. And we started off as a pretty small company. We raised about $2 million, controlling this little car here that you see on the ground using these gel cap sensors. And with that money, we went from these gel-based electrodes that they used in laboratory settings to something that in 2015 was dry electrodes. So it was just a cap without requiring gel. And eventually in 2018, we actually did our first reveal ever of our technology, which was a virtual reality system that integrated brain sensors on it and that enabled you to control devices using just your brain activity. And so really what we showed at that time is what was possible with brain sensors. What you could see here is actually some of our technology in play where somebody was able to play a virtual reality game using just their brain activity. They were able to grab objects and throw them and interact with different things inside the world. And all of this comes back down to software that we built at the company over the last 10 years to reduce hardware designs while still creating products that consumers want to use every day. And this has been about 10 years of work following a Moore's law of accelerating reduction in size and complexity, but we're really at the cusp of something so much greater. Let me give you actually an example of this. So what you guys haven't noticed yet is that this entire time I've actually been controlling these slides using my headphones. So I've not been using my hands. So I'll show it to you now that I debugged it a little bit. So I'm going to hold up my hands. So you can see that I was able to talk, I was able to move, I was able to do everything hands-free. The type of technology that we build basically allows for hands-free, voice-free interactions. The way that we see it is that this is the future of brain-computer interfaces. In the future, you're not going to have controllers strapped onto your body. You're going to put on one device. It's going to be a pair of augmented reality glasses, or it's going to be your Apple AirPods or your headphones. And that's going to be your computer. It's going to enable you to control your devices hands-free and voice-free. It's going to enable you to understand yourself and your own cognitive states better than you ever have before, because we're able to collect brain data over long periods of times. And it's going to help you diagnose mental health diseases even earlier than ever before. And this is really the power of brain-computer interfaces in everyday devices. And so that's really what Neurable works on. We work on technology that previously was in laboratory settings, and we want to liberate this to all the developers around the world. We want people to actually have a brain-computer interface that works for them and that works seamless. And so the product that we're introducing is a device called N10, and I'll show you just a quick video of what that is.
What if you could boost productivity and focus just by understanding your own brain? The N10 from Neurable, the smart headphones that tell you how and when you work best. N10 gives you scientific insights into your brain that help optimize your productivity and block out distractions. Whether distractions prevent you from getting through an onslaught of tasks, or you want the focus to make your aspirations a reality. N10 helps you stay focused on what matters most and win back time in your day. When you focus, your brain cells produce electrical signals. N10 has cutting-edge, soft EEG sensors woven into the ear cushions that detect these signals and interpret them using advanced signal processing algorithms. The Neurable app then translates your brain activity into data and insights that are practical and easy to understand. With N10, track how specific activities impact your focus and dive into trends that show when and where you focus best. Build better habits so you can optimize your day and avoid burnout. Plan certain tasks around your peak concentration times and schedule breaks for when you naturally struggle to focus. You can even learn what music keeps you in the zone. While you listen to your playlists on your favorite music apps, N10 will track which songs help you focus and offer recommendations for what to listen to when. These headphones adapt to you, learning what impacts your concentration and sharing real-time advice based on your cognitive state. N10 will prompt you to take a break when you need to restore your energy and focus. Or when you're in the zone, N10 will automatically cancel background noise and block notifications to keep you from getting distracted. Your privacy is our priority. Your data and personalized insights belong to you, are stored safely, and will never be sold to anyone else. Neurable is a group of leading neuroscientists, engineers, and veterans of the consumer electronics industry, with 27 patents granted or pending. N10 is only the tip of the iceberg of how Neurable can apply incredible science to improve your daily life. Future software updates will enable you to measure emotional states beyond focus, add new controls to your computer or mobile phone, and provide insights into the health of your mind and body. Support Neurable's campaign and help make frontier technology a part of everyday life. N10 from Neurable. Focus on what matters.
So that's really what we're building here at Neurable. Like we mentioned inside the video, this is just the tip of the iceberg. We have really started to break through a lot of the technology and limitations that have existed in brain-computer interfaces. We previously won an Augie Award for interaction systems in virtual reality, but really what we're delivering is the future of brain-computer interfaces to the masses. So with that, I'll pass things off to somebody else.
And the future of interactions too, right? So
yes, of course.
I have to ask, was it your eye movement that was changing the slide?
No, it was not actually. It was we're gonna reveal some of that more as I get farther down, but we have different levels of interactions, some that well, we'll talk about it later, but yes, we're going to be revealing that much later. And to our backers, this is going to be one of the few initial updates that we're going to be sending out to people who backed us on Indiegogo. But there's so much that we're doing with this technology. This is really just the beginning.
Can you put the link to the Indiegogo for people too?
Yep, absolutely.
So you can order one, but you won't get it for another year. I was so bummed. But I'm really excited to be a backer and to get access to the technology when it is available. So thank you so much. It's all of this technology is just so exciting, and can you imagine bringing the Omnicept together with what Neurable is doing? And let's add in some haptics, Dave.
Let's do it. It's always good to add that in. Okay, so I'm going to talk about how to touch things that aren't really there, which kind of breaks your model of reality, because we have this idea that the sense of touch is somehow tied in with like what is most real. But with haptics, which is technology for the sense of touch, you can virtualize the sense of touch and transport people to new places. So just a very quick background on Immersion. We've been around 25 years or more, and you probably haven't heard of us because we're not a consumer brand, but we build haptic technology and license it to many of the companies that you probably interact with. One of the most recent things that everybody's talking about is the PlayStation 5 DualSense controller, which has kind of the most advanced consumer haptic gaming features that have pretty much ever been released. It has 2 triggers that are kinesthetic, meaning that they can move your fingers in and out. They can provide resistance. So depending on what you're doing, if you're grabbing something, if you're shooting a weapon, whatever else, that trigger can give you feedback and virtual sensations. And then it also has HD vibration, meaning very high definition vibration in the palms of your hands that can that can show textures and surfaces, as well as like the rumble that you're used to in gaming. So it's very high resolution. We play with these types of things in the labs all the time. And so I'm going to share with you today a few forays into augmented reality and XR that we've made over the last few years and share some lessons from that. Go through this really fast. Your sense of touch is complex and different from the way that other sensory organs work. You feel in at least, you feel mechanical deformation of your skin and your body in at least 4 channels. You have additional channels for thermal, pain, others. And so as a haptic designer, knowing this is knowing your craft. But ultimately what haptics can do for an interaction is make an interaction more intuitive, because it leverages something called embodied cognition, which means that your body state and your sense of touch and posture and movement actually affects what you think and how you think about the world. And so as a designer, you're thinking like, well, if I can provide somebody with haptic sensation in this way, then I could get them to understand something or do something. It's also universal. So, there are haptic, there's haptic meeting or touch interactions that transcend cultural boundaries and languages. And it's also more memorable. So if you have a haptic sensation that is synchronized with other inputs like visuals, for example, you're going to be more likely to remember that, that interaction. And so these are all useful tools. And it can become very concrete. This is one of the pieces of desk research that we've done over the years. There's others, but you can actually boil down the sense of touch into parameters that can be used as design patterns. And so if you're trying to convey a particular emotion or meaning, you can have a design space that you need to utilize as a designer, and then that will then tell you like what the haptic system needs to be capable of in terms of its display. There are many different modes of haptic sensation. It's different from hearing and vision because it's really a basket of a lot of different senses, the sense of touch. And it can mean anything from vibration alerts, which could be notifications on the phone or other more advanced vibrations on the phone that can tell you kind of how many messages you have, not just that you have a message, or who's calling you, or a sticker that has an animation that has an emotional quality to it. Or it could be something like lane departure warnings, which are feeling very natural because they actually simulate the crossing of a lane line with bumps on it, right? So haptic designers can kind of utilize or like import your expectations for the sense of touch in the real world, and that's a really powerful tool. There's also game immersion, which I talked about with the DualSense. Rich communication, so interpersonal communication is really a huge value of haptics. It's a highly emotional and intimate modality for social interaction. And then surface haptics, so you can actually send energy through a surface, just at a high level. Won't get into the technical details, but you can do that to a surface such that you can actually change its friction or its textural qualities. So when the device is off, it feels smooth, but when you turn on the device, you can play haptic effects that make it feel rough or sticky. Kinesthetic, we talked about the triggers on the PlayStation DualSense, but there's also gloves that can prevent your fingers from closing, so you can have a virtual grasp. So then you put your hand out in VR, you're wearing this haptic glove, and you close your hand around, let's say, a doorknob. And when you do, you'll feel a cold sensation of the metal, and your fingers will stop moving because motors will prevent them from closing any further. So you have a very high resolution sensation of grasping an object. And then that scales all the way out to exoskeletons. And then you have other things. You have thermal feedback, which is a really interesting modality. And then you have contactless haptics like Ultraleap. They're doing really interesting work with ultrasound to create haptic sensations that are mid-air. But haptics is uniquely challenging for designers because you need the entire stack, and it's highly reliant on kind of the weakest link there. So for example, the design tools are not that advanced. We're working on that, but we really want to unlock haptics as a creative medium, and that's a real challenge. Software, so the codecs don't tend to be, and the APIs don't tend to be cross-compatible and interoperable yet. We're also working on that, working with standards organizations to standardize haptic coding, and that's going to be a key thing that happens in the next couple of years. We're making a lot of progress there. And then on the hardware side, you're limited by what the hardware can do. So you need an amplifier for the haptic signal, and then you need an actuator. The actuator could be moving, it could be spinning. You know, there's many different things it could be doing to create this sense of touch. And so what's interesting right now is that we have this marketing term, the tactile internet, which has cropped up in the last couple of years. And it was part of the way that the carriers and other technology companies were promoting 5G and that, like high bandwidth, very low latency, wireless communication that's highly available and highly reliable. And the thinking behind that term, the tactile internet, is that if you have a wireless network that's that reliable and low latency, then you can start to create applications that are not dependent on a particular location, but can be can have a gesture in the loop. So in other words, the classic example I always think of is you could have sensors on a bodysuit or a glove, and you could be controlling a robot very far away, and that robot could have sensors on it. And when the robot touches something, you get an immediate tactile sensation, and then you can use that to adjust the behavior of the robot in real time. So it really is a transportation of your sensorium to another place, and it's kind of that vision of the avatar that you can control in real time. So that's the vision, and there's probably a lot of different things that will happen before now and then that will be interesting as well. So yeah, so this is an AR talk. So I wanted to talk a little bit about a couple of the things that we've worked on in AR. So what you see here is from a couple of years ago now. This was called ART, T for tactile, but also art. And the idea was that we were going to build this ring that was going to be able to play like organic sensation. So instead of just vibration, the ring that you see in this picture, do I have a picture of it? No. The ring that you see in this picture is very thin, and it's made out of a smart material that can actually move kind of by itself a little bit. It can squeeze your finger a little bit and flutter. And so it can create these sensations that kind of feel like liquid. And so we wanted to use that to create a painting experience that was more realistic. Here you see how it turned out. So this was a few years ago. This is a HoloLens one, I believe. Oh no, this is a different one. We also had it on HoloLens. This is on the Meta.
Yeah.
But yeah, so you can see here that actually she's not using it, but the palette that she's using, we were trying to track the palette. We are using electromagnetic sensors for this. We really struggled with mapping virtual onto the real world. But one of the coolest part, this was cool. She's painting a silhouette around a person, and she just started doing this kind of organically, and it was kind of a fun thing that she figured out how to do. But here you can see picking up paint is like sucking it out of a blob of paint, and you can feel it like entering your finger. And then when you paint, you can feel it exiting your finger. And then when you're out of paint, you stop feeling that sensation, and you kind of, it's a cue to go back and like pick up more paint from the palette. So the idea was that we were kind of making a more natural painting experience. Full disclosure, we didn't get video of it, but a professional, like a well-regarded painter who has sold artwork came by our booth. And I said, just try it, paint like you would normally paint. I didn't realize that she makes these canvases with like incredibly intense lines and brush strokes. And she wound up like going to town and like pulling on the wires. And it was just like, she was like, this doesn't work for me. So it's like, I think you've nailed it when you have like a picture of paint in 3D, but actually like a painter and the way that they interact with paint can be very different. This is another project. This was more oriented towards the 5G and the tactile internet. So this is called the Haptic Cuff. And the idea here is that this cuff is going to have a lot of different haptic modalities on it. It's going to have an array of vibration actuators. So you can see them there. They each have an LED and a vibrator on them. It also can constrict like the ring, and it also has thermal feedback, both hot and cold modalities. And this is going to be your 5G interface to the tactile internet, and be able to go through the world and like feel this layer of haptic AR on the world. We made several scenarios, and it was really interesting because we tried to find interactions that were meaningful, but that didn't require any visual or other modality whatsoever. These are scenes from a story that was told about this, where this guy is at work and he sets up like a dinner date with his friends, and he goes out, but all of his interactions are with his agent, his virtual agent, and she is able to interact back with him and tell him like she's found a restaurant or his friends are late, anything like that, as kind of like this emotional, personal communication that's right on his wrist. And then she's able to like hop to other people's wrists and talk to them. And so there's this idea that you could like fuse, agent and assistant technology with haptics in a way that would feel natural. And this is part of the prototype that we built. We built several prototypes that were kind of in different pieces. This is the part that was thermal, I believe. And so, yeah, we're finding really interesting effects when you combine things like combine different haptic modalities. You get like meanings that are just like completely unexpected and intense. For example, if you play a very gentle squeeze on the wrist and you combine that with warmth and you synchronize those in the right way, it feels like a gentle hug, like a warm embrace. And it really communicates like love and affection in this way that, I don't know, you can't really appreciate till you feel it. You're like, wow, that feels like really nice, you know? And so finding, making that whole haptic stack work just so that you could discover that design pattern or that design opportunity is a real challenge. So haptics people, we have our work cut out for us, but as we go forward into the next few years, we're going to see more and more standardization and more design tools that are available and kind of make all of this easier. I threw this in here at the last minute. We've been having some really interesting conversations on this panel about human motivation and how you can relate human motivation to these like superpowers that these drives for superpowers that people have that persist throughout mythology and story for thousands of years. And actually part of the Cuff project and the way that we like organized that design work was around these motivations. So the motivation to explore, which in its superpower form is translocation, your ability to just like teleport, your motivation to achieve. So the superpower version of that is omniscience, or like being all powerful and all knowing. You have a motivation to enjoy, so being entertained, etc. And the superpower is to just conjure whatever you want whenever you want it. And then your motivation to relate to others. And superpower form is like telepathy, knowing what people think and anticipating what they need. And then your motivation to thrive, and your superpower there is immortality. And so these 5 things, they keep coming up over and over again. And you think of virtual reality or augmented reality, it's really the fusing of like fantasy and reality. And so understanding these kind of can point the way to some really interesting design opportunities. And again, that was part of the motivation for some of the use cases that we found for the Cuff. And yeah, that's it.
Okay, Dave, thank you. So many interesting things are being presented here tonight. So it's going to be a rich conversation. Simi, why don't you bring it on home, because your work is probably the most comprehensive. Where are you? I think that you're using pieces of all of this probably in different ways, or at least are planning to. So why don't you talk to us about your master's thesis and a little bit about what you're doing at Magnopus.
Alrighty, smart spaces. I think we can dive right in and go to the next slide there. So let's define smart spaces for the audience real quick. So we can define it as a physical or digital environment in which humans and technology-enabled systems interact in increasingly connected, coordinated, and intelligent ecosystems. So there are multiple elements that are part of smart spaces, including, people, processes, services, and even objects. And these elements come together in a smart space to create more immersive, interactive, and automated experiences for a target set of people or industry scenarios. So here are a few, smart space examples at different scales. Smart homes, I think a lot of us are familiar with these devices listed here. We have smart buildings and smart cities as well, which I'll be touching on a little bit later in this conversation. All right, next slide. So I wanted to share with you guys a little throwback. of some of my early thinking around sensor-driven spaces. This project is actually from my master's in architecture thesis from UCLA circa 2015. And I'm guessing it's aged somewhat well since we're talking about it today. So next slide.
It's still relevant.
So the Kinetic Catalyst is essentially an environment that is designed to respond to natural human behavior by, oh, Susan, we could go to the next slide there.
Yes.
So yeah, responding to natural human behavior by enhancing the relationship between a performer and an audience, and doing so through an architectural medium. So this pavilion goes from like an enclosed private structure in the daytime to a lecture or a dynamic backdrop for a performer at night. And so the kinetic motion and the lighting systems that are built into this pavilion are actually powered by the performer's brainwaves. So we actually built a physical prototype of this kinetic pavilion where we tapped into a couple of channels of the emotive epoch device. It's a 14-channel EEG, and we tapped into focus, engagement, and stress. And we linked those 3 channels to LED lights on the pavilion. So essentially the idea here is that there's this feedback loop, and we can jump to the next slide here, where the performer's emotions are translated into brainwaves that are picked up by the EEG sensor, which are then programmed to alter this pavilion's environment, which then impacts the audience's behavior, responding to the environment, which can then go back and influence the performer's emotions, and so on. So yeah, next slide. So we had to build out a VR component of this experience. And the idea here was that, if you don't have an audience that is present on site, how can they experience this rich, ever-changing environment remotely? And so we created a digital version of the pavilion, and the concept was to link the lighting and the environment tied to the EEG in real time. It would have been really, really nice to have access to the Nearable, but this was before that time. But yeah, so, understanding how people could access sensor-driven physical spaces remotely to not only experience these spaces, but to potentially even track them or participate in the space in real time from anywhere in the world. And that kind of leads into what we're working on at Magnopus, which is the next slide. So we're working on uniting the digital and physical worlds to create unified user experiences that can exist across this reality spectrum and across different devices. And we're working on enabling people to create and consume spaces across this reality spectrum. Just as an FYI, most of the things that we work on at Magnopus tend to be highly confidential. So it is with intention that I speak of this work at a very, very high level. But if we jump to the next slide, we could talk a little bit more about these digital and physical spaces. So we're working on large scale sites that have a digital twin and an experience layer that connects occupants not only to various pieces of content, but also to other users as well. And what we're building at Magnopus isn't just to optimize physical realities via the digital, but also provide operators, decision makers with the tools to be able to do so. We can jump to the next slide there. And again, we can see this feedback loop. So there are many different use cases for this technology, but for the purpose of this conversation, let's look at smart cities and the value proposition there. So like I mentioned, we see this feedback loop again between the digital and the physical when looking at how these smart cities can function. So from the top, essentially a smart city is an urban area. It uses different types of electronic systems and sensors to collect data. That data is then translated into insights that are then used to optimize and improve operations across the city. And then the quality of life as a result in these cities will drastically improve, and they're set to become more efficient with better services. So then we see the shift in how cities function, and therefore we see a shift in behavior. And when there's a shift in behavior, we start to, or the data starts to tell a different story. And then we could take that data again and make appropriate decisions from there. Now, when you think of smart cities and just like the density of data that is collected all at once, you might picture something like this, the next slide.
Okay.
So I think we've all seen these images at some point, and it looks really cool, but as a user that has to consume and synthesize this data, how does that make you feel? I could tell you how it makes me feel, and I think it is anxiety inducing. So, you know, cognitive load is a real thing. TMI is a real thing. So I think there's this like dichotomy of like what we expect between 2D interfaces and 3D information in context of the world. And I think it is our responsibility as designers to think about ways in which this information should be sorted, filtered, and served up to users. And so I think the challenge is to filter out the noise and to be able to provide actionable content in context. So, you know, you can do so, or you could start to do so by empathizing with your users and understanding what their needs are. And I think that that is, you know, one of the core principles when you think of human-centered design. We can jump to the next slide. And I'll leave you guys with a couple of what ifs here. So what if we had access to all of our relevant sensor data in one place, you know, where we can access it on the device of our choice? What if we could customize our digital interfaces to control these sensors in real time and at scale? What if we could visualize all of this data in context, remotely and collaboratively in order to make better decisions? So this is some of what we're working on and working towards at Magnopus. And I'm looking forward to continuing the discussion on other possibilities and use cases and design considerations, since you know, these will be critical pieces of information as we construct the future of smart spaces.
That's awesome, and it's great that we make a full loop back to cognitive load, which is where we started with Elias. So that was quite serendipitous and unplanned. Wow, I'm so blown away. Thank you so much for diving in and into the details. And I know that took up a little bit of time, and we definitely want to get to the conversation. But I think having that context of what people are working on is really helpful and important. It's certainly, you know, I learned a lot, even though I've been talking to each of you, you know, at various times and knowing about your work. So, wow, that's just like, I get so excited when I hear about all these different things and how they are coming together. And I had questions where I wanted to start, but now I'm just like blown away by everybody's stuff. So I love that you talk about the cognitive load of the data and the overstimulation of the senses, right? That's so much what Ramsey's work is all about. I think it's so needed. I know I'm dying to have that product because I desperately need it. And, you know, Elias, you're also talking about measuring cognitive load in your work. So what tools and devices, Simi, are you guys thinking about in terms of managing and designing for cognitive load? Do any of the products that you saw tonight, you know, I doubt you have Omnicept, you know, and Enton in your designs at this time at Magnopus, but you guys must be thinking about it in some other way.
Yeah, honestly, that would be great. I mean, I can imagine us using the Omnicept as part of our, like, you know, user testing and part of our design process to make decisions in terms of how we want to build this out. So yeah, I'd probably want to hear more about what Elias has to say about this.
Yeah, absolutely. I mean, the technology, I tell you, this is just the beginning for HP, right? I talked about cognitive load. It's going to expand way more. Like, of course, I can't talk about the roadmap, right? That has to come later on. But we are planning as a first step cognitive load. Then you start, as I said earlier, start talking about emotions, right? And then the list goes on and on after that. So I think what we talked about collectively today is all connected, in my opinion, and I'm glad that it is connected somehow, right?
Yeah.
I mean, Ramses, what you showed it to me is phenomenal, right? I mean, connect the dots between what you talked about and what Omnicept is, right? Eventually, right? There is a connection,
Oh, yeah,
definitely.
Absolutely.
Yeah,
for
haptics
sure.
is no brainer. I mean, definitely is, right, for sure, right? So we are excited about all of these technologies coming together, and I'm glad forums like this educate people on what's available and what could be the potential moving forward.
Yeah, definitely.
Really, what's really interesting to me is that right now, all these ideas and devices are separated, but in the near future, they're all going to become together. You know, we're going to need feedback. We're going to need, and it's going to be for a holistic future where we do our learning in immersed spaces and in immersed ways. We're going to need to understand the brain. We're going to need to understand how much load a person is. And that's actually one of the projects we have going right now. We're working with the Air Force and we're trying to understand our individuals' learning material, right? Because their attention is tied and their engagement is tied to how well they learn material. And so by picking up brain data, understanding cognitive load, providing immersive environments, providing immersive content, and actually having them feel what they're working completely changes the type of people that we can create. And I think it's insane. Right now, I pick up a book and I look at it like a math book. And I think to myself, like, wow, you know, it took people hundreds and hundreds of years to accumulate what is in this one book right here. And I'm learning it just by reading this book. Right. And with the technology that we're all developing right now, we're going to be able to do that 100-fold better for our future, for the future in front of us.
Dave, I remember you talking about that haptics can, I know I'm not going to get it exactly right, but haptics can work on the subconscious layer or underneath the conscious to help like direct and whatnot. So how can you see haptics helping to reduce the cognitive load if it's able to work underneath the conscious?
Yeah, no, I was actually thinking about that. I didn't mention cognitive load, but we think about that a lot in haptics also, especially because in our view, and it's obviously centered on haptics, but we believe that sometimes there's information that is conveyed visually or auditorily that really is more appropriate for the haptic channel. And the result is that the haptic sense is like underutilized or starved or whatever, neglected, and you have clutter in the visual field or the audio field that you don't need. And, you know, I mean, just something comes to mind right now, you know, the design pattern in a streaming video of like the heart's bubbling up when you like something. I mean, that's really a workaround for the fact that you can't have like an affectionate haptic interaction, right? It's a hack. Like it's using an icon of a heart to represent affection instead of just be affection. And so that's just one example. But yeah, when you add that up, then you have a lot more cognitive load perhaps than you would need if you could naturally convey meaning through the sense that's most appropriate for that type of information.
Yeah, and I think also, Ramsey, I want to look to your work in interaction design. Really sounds amazing, because I think that it sounds like you're on that path too of reducing cognitive load by taking the interactions out of the visual field. And I'd love for you to talk a little bit more about your design process and how you guys are addressing designing those interactions.
Yeah, absolutely. What I would say, I mean, it's been 10 years worth of work to really understand how to develop where we are as a company and the types of interactions. And to be honest, like most of the time when people think about invisible interfaces, the main type of interface that they think of is voice. So you don't use a screen or anything to interact with. And with brain-computer interfaces, like voice is like 10% of what's possible, right? And just to give you an example, when you're talking about brain-computer interfaces, we really kind of think of two ways of doing interactions: passive interactions and active interactions. So for example, with the passive interactions, you can take the N10 headphones, you could wear them, and then when you start entering focus on your task, we will automatically turn on noise cancellation on the headphones and put you in do not disturb mode on your computer and your phone. And that happens passively, right? And then as you start weaning, you're getting tired, etc., we can tell you, hey, you need to take a break, or we can automatically play music that can help you maintain focus for a longer period of time. And people don't think of interactions because we haven't had these kinds of examples as interactions for the most part, right? When you think of an interaction, you think of something you volitionally do, right? But with brain-computer interfaces, you can start to understand intent and provide value to the user without them even really noticing. Oh, it just benefits their entire life, right? And then you obviously have the active interactions, like I use for controlling the slides, or I can use it to mute and unmute Zoom, and there's so much more. So the design space is enormous. And at the same time, too, the clutter you can create is so much more. But with brain-computer interfaces, you can also start to understand what a person wants and does not want. And that actually helps you remove clutter. If they don't want this information, don't give it to them. And so I feel like in the next 5 years, we're going to start, especially as AR starts to really gain a lot of momentum, we're going to enter this kind of landscape where people are going to be bombarded by information, and we're going to need new tools to know what not to give to a user, right? Because just imagine wearing an AR goggle, how much information per second can be given to an individual. And so really the trick is going to be, how do we make sure that we give people what's relevant and valuable to them?
And Ramsey, interesting that you mentioned that, and you presented about, I think you said that the headset will automatically do noise canceling, right?
Mm-hmm.
So that's not even not presenting, that's actually actively blocking things out and exactly. Kind of like predicting what people will want. And there's this term I learned a while back called diminished reality. So it's this idea that you can use AR technology to actually cut away parts of reality to kind of showcase or isolate what people actually do want to see or interact with. And it strikes me that that's kind of what we're talking about here, that this technology can be used to let you focus by actively blocking out what you don't want to see or hear. It's cool.
One thing that we do if you come to the office here is we can run you through like a little test. And the test has you do a very simple scientific task where you're supposed to maintain your attention. And then you do that task, and then you repeat it with distractors that are common in an office environment, right? So in the first one, we're using, in a way, diminishing reality, because we can turn on noise cancellation, we can turn off do not disturb mode. And then when you go through it the second time with the distractors like Slack notifications and calls coming in, you can actually see, essentially we print out a receipt that says like, this is how much you lost in productivity during this period of time, right? And that is just so empowering as an individual. And I suffer from ADHD. And so having this type of information for me, especially because I'm more susceptible to situations like distractors, has been really helpful for me personally. But yeah, that concept, and I'm glad you brought up the word and explained it beautifully, but that's exactly where I think a lot of the gap that people aren't looking at exists, that we need to learn how to diminish information as much as we need to know how to augment it.
And I don't think that's something that's 5 years. I think it's now. No, seriously, even just with the internet, I don't know about you guys, but sometimes it's just really frustrating, and I'm being bombarded with information when I'm trying to get something done. And it's so easy to go from one task to the next. And then like 20 minutes later, like, oh, this was the thing I was trying to get done. So yeah, I don't think it's in 5 years. I think it's now. And then in 5 years with spatial computing and augmented reality, yeah, it's unimaginable without thinking about how to, and this is something that you talked a lot about too, Samina. I don't know how much you can talk about the ways in which you're thinking about and designing for sorting and filtering and serving up appropriate content in the right context. Can you say more about that in terms of the tools you're doing, using the approaches that you're taking?
Yeah, well, I think, Susan, it depends on the use case. And it depends on, I think understanding what or anticipating what your user's needs might be. And in order to do that, you need to understand your user. So I think one tool that we've been looking at internally is empathy mapping. So, thinking about like, what is your user thinking? What are maybe some things that your user says? How are they feeling? And then through understanding various aspects of your user and the jobs to be done, the work that they do, the actions that they take, you're able to kind of understand what pieces of information are important to them. And you're able to make decisions in terms of what needs to be filtered accordingly.
And then, Elias, do you have more that you want to say about, I don't know how much feedback you guys are doing in terms of customizing and altering the user experience based on the biometrics that you're getting, or are you pretty much using it for analysis?
No, actually, as I said while I was talking, Susan, one of the areas that we focused on is after action review as well. And I gave the example of if you're getting sensory from the headset itself through the SDK, that this person or that person are not up to task, then you can actually tailor your VR application for them. Whether it's a surgeon not knowing, they say surgeons usually make mistakes first thing in the morning, right? So imagine teaching a surgeon before they go into a actual surgery on a VR to get them like warmed up and things like that. So all of that feedback from the headset through the SDK with cognitive load and intelligence coming through the SDK and artificial intelligence will actually help, right, for tailoring that VR application to do what's next, right? A pilot is failing the training, do something different. A soldier being trained to fight in policemen and or policewomen, all of these things are unlimited in my opinion. The sky is the limit for our.
Ooh.
I think
Elias, you dropped out.
Oh, I dropped out?
Yeah.
Can you hear me?
We can hear you.
I can hear you.
Okay, you're back.
Yeah. Oh, okay. I'm not sure what happened. Where did you lose me? Did you lose me at all of it, or?
You were kind of going in and out, and just
sure
for the last bit, we lost you completely.
So there are a lot of ways of using the biosensories from the headset itself, right? And as I said earlier, that's just the beginning. What's coming later on, I explained about emotion. And emotion is definitely a hardware play and also a software play as well, right? So, and by the way, that face camera, it sounds like a simple thing, but it's not. You're gonna be able to determine if you're sad under that experience, if you're happy, if you're excited. And then we're also gonna sense the muscle movement as well. So again, I don't wanna throw a lot at people listening to me, but add all of these things and take it into the SDK, into VR application. There are, like if I look at our ISVs, what they're developing today is mind-boggling, honestly. I mean, I have around 58 people building applications. When I say people, I mean ISVs, independent software vendors, started to build applications to take advantage of all these sensories and cognitive load to start with, next expressions, and then next is emotion and whatever comes after, right?
Right. So Dave, you talked about, it was really interesting that you're researching and learning about combining different haptic modalities to create the experience of a hug from different haptic interactions, like just at the wrist. have you thought about, or based on this conversation tonight, can you imagine bringing in this other sensory information and combining that to create specific kinds of haptic experiences?
Yeah, absolutely. I mean, it's there's a lot you could do because well, actually, Elias was talking about emotional recognition on the face. That's a really interesting avenue. So, you know, you don't need to represent that emotion visually. You could represent it haptically, like with on the wrist. So that's like one application that comes to mind. That could be really, really cool. You could feel what another person's facial expression was, and you know, maybe that could even assist with people who have trouble recognizing emotions on faces, or you know, long distance or whatever. But yeah, there's a lot there, and we've looked a bit at biometrics, and I think that again, kind of like the AR struggles that we had with tracking, one of the things that has limited thinking around there is the lack of the platform that's just reliable and usable, ready out of the box. And so the Omnicept looks really cool for that. Like, you know, being able to easily prototype and iterate through ideas is really the power there, I see.
That's great. Yeah. So pretty soon I want to open it up to questions from the audience. But I do know that we had one question, Dave, about, you talked about developing tools to make haptic design, you know, easier. And someone asked like what those might be, or what your thoughts are on that.
Yeah, it's tough because I was saying in the chat, there's no reference device for haptics. I should have mentioned that in the slides. Like for visuals, we have a screen. It's like an array of pixels, and there's different sizes, but they have colors and they have brightness. And there's like a thing that everybody uses for visual design, which is called a screen. For audio, it's speakers. You know, you could have different numbers of speakers and quality levels or whatever, but you have speakers. And everything follows that. In haptics, like it's really, like I said, it's like a basket of different technologies that engage a sense of touch. So there's no reference device. So what that means is that you're often designing for a particular application. There are certain things like mobile phones with vibration actuators. They're not that versatile when it comes to haptics, but they're at least completely stable. You know, there's like 2 billion people with a vibrating motor in their pockets, and you can make interesting experiences for that. That kind of preserve design intent all the way through the process to the end user. But yeah, you're gonna see, as we standardize parts of the haptic stack more in the future, you're gonna see more opportunity there. There's actually, for example, the Haptics Industry Forum is a new industry consortium that's only, you know, a year old. And we're making a lot of progress creating specifications and recommended practices. And so there's an example of something that, you know, it's only a year old, so we haven't made a lot of progress yet, but the industry is finally kind of like solving some of these problems. So I'm hopeful that in the next few years, we'll see some progress.
Do you want to put the link to that in the chat?
Sure.
Yeah. So it's right on 8 o'clock now. So I think, Ray, have you been pulling questions from the chat?
The question that you just referenced is kind of the only one that's really had, but I mean, I think it's a great opportunity to open it up to our audience and see if anyone has something they'd like to say.
Okay. So do we want to, I don't know if it's just my view, but is it still on Spotlight, or is it regular now and I'm just, okay, it's on regular now. Yeah. I don't know if people just want to raise their hand, or
I'd say if you wanna ask a question, why don't you ask it in there, or just kind of post in the chat, and we'll unmute you, and then you can ask it live.
I have a quick question for Elias. I'm curious to know how you guys are collecting the biometric data. Do you guys have like an analytics dashboard or an analytics platform that's tied in?
Yeah, as I said, you know, remember the SDK, you have to use our SDK in order to get to the data, right? So the data sensory coming from the headset, whether it's heart rate, whether it's eye gaze or pupillometry, all goes through the inference engine. I don't know if you remember that slide I showed. There's an inference engine, SDK, and there is an API. Now, if you would like to take that data, raw data, and manipulate it somewhere else, you still have to go through the SDK, the API, and get that data. So you can take it and do whatever you want with it. But if you want the cognitive load, we provide that information out of the SDK right away. Does that answer your question? Is that what you wanted, Simi?
Yep.
Yeah.
Sounds great.
And by the way, you can download the SDK on hp.com/Omnicept, right? I can put it in the chat, right? And take a look at it.
You know, there's a couple of things that we did not talk about, and I want to talk about safety and security, especially I think Ramses and Elias. How are you guys making sure that your products are safe for individuals in terms of the data that you're collecting?
Sure.
That's always a question that people have.
Sure, I can, if you don't mind, Ramses, I can go first, right? So remember, our headset does not store any data in it at all, right? It's a, I hate to say it, dumb headset because it's intelligent, right? But it is no storage of data. It is connected to a laptop or a desktop. So all your security measures you put in an organization. And by the way, I failed to mention that our headset or our solution is targeted for commercial and enterprise. Maybe I did mention that. But so any policy you put in place on those laptops or desktops applies to all the security measures you have. And then if you notice in the video that I showed on the SDK, we comply with GDPR, which is European security policies in place. So there's a whole slew of FAQs that we'll post on the web, talks about security as well for our Omnicept edition.
Okay.
Yeah, that's a really good kind of thing to, there are some regulations out there on how to store data, and definitely that's something that we're going to be following. At Neurable, it's part of our DNA to care about personal privacy. And it's been something, we say it in every single thing that we do. We don't make money off of your data. We never will. We encourage those that are part of our community, which many people are, to share their data, to share it with us, to help us build a better product. But it's your data at the end of the day. If you want access to it, you can have it. If you want to share it with us or anybody else, you can. It's going to be de-identified. We follow higher standards than some regulations that are out there at this current point in time. We're going to be releasing a whole slew of information regarding that as well too. But what I think is really important is there's a lot of ways that data can be violated in a way that makes you feel safe. So for example, giving this to employers, giving these to enterprise, right? What if your boss could see that you're not focused, right? Like that's not what our intent is. And we're never going to sell your data to an enterprise for that type of approach. We talk to groups who want to use our technology at a larger scale, and we tell them, that's fine, you can use it at a larger scale, but this data is going to go directly to the person using it. And if they want to be empowered by that in order to be more focused or restructure their day, to know when to do their most high impact work, when to do their emails, et cetera, that is up to them. And actually by allowing people to be empowered, you actually see them make those changes and providing them feedback that they can see themselves. But there's going to be moments you're going to have a crappy day. And that's not when you want somebody to be looking over your shoulder. And so those are kind of parts of our DNA that we're really, that we think are very important.
That's really great to hear. Simi and Dave, do you want to say anything on this topic?
Yeah, I actually had a question for Ramses on that actually. So have you guys seen as part of your research that, as users utilize this technology, they get into a habit of focusing better over time? I ask because I've been a user of the Muse headset, which is like a meditation EEG headset. And you kind of learn, like, so basically, to whoever doesn't know about the Muse headset, you basically go into a meditation session that's like 5, 10, 15, up to 30 minutes. long. And at the end of your session, you get a little graph that shows you how long you were focused, how long you were, distracted. And it basically shows that over time, it trains your brain to stay in that like focus zone for a longer period of time, which is really cool. So I'm guessing that scales to what you guys are building out as well. Have you seen that as part of your research?
Yeah, that's a really good thing to point out. And that is through practicing, you will get better by yourself. And what I think is really interesting is that one of the things that we can do is that as you're working, it's very natural for you to mind wander. And the reason for that is it's actually an evolutionary reason to mind wander, to get distracted, because it keeps you alive. Imagine that you're doing a task and you hear something in the bushes, and it's a lion or a tiger, and it's going to come get you, right? So this is a very natural process for your brain to want to do. And so we try to do things that enable us to leverage those natural processes to actually train you to maintain your focus longer. So if you start to become distracted, we'll actually play a small tone that, as we see you getting out of focus, reminds you to go back into focus, right? And so by doing that, you start to be able to do it more yourself. And later on, it basically trains those neurons in your brain. Plasticity gets into account, and you're able to do your at least that's how, seeing my information, I've been able to benefit from it significantly. And so you're going to start to see this type of technology really help a lot of people from that perspective.
And have you guys considered including like some form of gamification as part of what you're building?
For the initial system, we haven't necessarily gotten to that point, but it's something that we're definitely thinking about. Gamification is such a huge motivator, and it's really interesting how what we've seen is that this is like, to me, this is absolutely fascinating, by the way. But what we've seen is that somebody who is tired but motivated will do better than somebody who is rested and unmotivated. And this is also something that has been seen in research as well, too. And so what if you can leverage both of those mechanics together? And video games do an incredible job of this, to the point that, some of the loot box stuff that's happening right now is incredibly predatory, right? Essentially it's like gambling, right? But you can learn to provide yourself motivation or find ways to motivate people. And I think that, with technology, like obviously N10 and also what Elias is working on, it enables people to start to develop this, but for the good of use cases, for learning applications. And I think that's really, we're at the beginning of that. Awesome question.
Looks like we got a question from Oscar. Oscar, you wanna ask your question?
Yeah, I was just curious, kind of a little bit leading into what Simi was talking about. So I was just wondering about the level of personalization of some of these devices. So like the Neurable headphones and Omnicept, for example, because kind of like Simi alluded to, I think there's this kind of notion that normalcy is kind of fluctuating over time, and that there are a lot of external influences that might impact some of these users. And like as time progresses, they might progressively get better at productivity or even worse. And so I'm just wondering how some of these devices are kind of tackling that kind of more external influences and over a longer time frame.
Yeah, I'll kind of just jump in there real quick. What we actually found in one of our studies is that environmental factors determine 80% of your performance, compared to just, our algorithm alone, right? If we were just to look at attention changes due to an individual, while it provides us a lot of feedback, actually, like how much sleep you got, what happened, stuff that we can't account for impacts you far more. But I mean, 20% of what you're able to bring to the table is still pretty significant, right? And so, but on top of that, how could that information be used to help the rest of your 80%? If you know that you need a break, right, for your own mental well-being, if something tells you that you need to go take a break, that ends up helping you holistically, right? And so really becomes this feedback cycle. And Simi kind of touched on this, and so did Dave, which is it's a whole feedback cycle of information coming in, information coming out. And really, we're just starting to develop the technology to tap into that cycle.
Eric in the chat had a great question as well. You know, we look into our cyberpunk future and we see kind of what we're building now. We know what the kind of William Gibson version of this looks like, right? What is the impact of eventually these sensors and these sort of things being implanted into us? Like, are we moving towards a future where these sort of things will live in us eternally, or will, you know, there always be advantage of these things being external people?
The short answer is no, not yet. You know, it's you know, I love what Neuralink, Paradromics, so many other incredible companies are working on invasively. But the way that invasive works for the very long foreseeable future is you're probably not going to get it unless something goes wrong, unless you have epilepsy and you need surgery already. You might, you know, for example, you become a quadriplegic or you have severe ALS and you need to communicate to caregivers. The risk reward, the risk of getting a surgical implant is just so much higher compared to the reward. But that doesn't mean, you know, anything negative from that end. We still need that, right? There's still millions of people that will need that technology, and there's still a lot of advancements that eventually will become incredibly useful. If I were to compare kind of where we are invasive and non-invasive, invasive is like getting a prosthetic limb, while non-invasive is like buying a pair of shoes, right? It gives you a lot of value. You know, imagine running in boots, right? That's not fun. Right, but people used to run in really awful shoes before, you know, the sneaker came about. So there's definite significant value that you can pull out of the technology now. It's just more for a mainstream audience, non-invasively, while invasively it's more for specialized applications. That's my opinion, but I'd love to hear other people's thoughts.
I just wanted to say thank you, and I'm a UW student right now, so go Huskies.
Go Huskies!
We have a really interesting question, but I don't know if they're still online. I'm not sure how to pronounce your name. GQ? Jaichi. Oh, they left. They have a really interesting question about emotional fingerprints. That's really interesting in terms of some of the things you were talking about, Dave. And I don't know if anyone else can talk to that. So the question is, does the emotion recognition technology assume that there's a one-to-one mapping between an emotion category such as anger or fear and a specific autonomic nervous system response pattern, i.e. face muscle movements, brain signals, or would it be personalized? Would you think about the assumption? What do you think about the assumption that these are emotion fingerprints?
That's a big question.
It's a great question.
And it's a big one, and it's a big discussion. So I needed someone from HP Labs to talk about this, right? It's really an interesting question. Yes.
Yeah,
it's a PhD question right there. You know what I'm saying?
Yeah. I'm no expert. I don't have like a PhD in psychology or anything, but so I'm not going to describe this perfectly accurately. But my understanding is that there are certain facial expressions that do carry over across every culture. There's a few of them. I think there's only like 3 or 4, and then the other ones are dependent on culture and context. And then the other thing I think of with that question is there's like this classic juxtaposition of valence and arousal in emotion. So you can use sensors to capture people's arousal levels very easily. So like how aroused they are emotionally, but you can't really tell valence very easily. So it's much easier to just, like, for example, you would confuse anger with excitement. One of them has a positive valence, one of them has a negative valence, but to the sensors, they can look similar. So my understanding is that's kind of where it is. It's like really easy to find that first part, and then figuring out that second part is more difficult.
I'd be curious how like muscle movement, I would imagine that's a big factor that may be able to you know, tell the difference between anger and excitement, but we don't, I guess, have anybody here that maybe can answer those questions outside of the expertise of this panel. But yeah, it's an interesting question because, you know, people are concerned with the Quest and the data that they're collecting and being able to identify people based on, you know, like their movement and their posture and things like that. So I don't know if you guys have any thoughts on that, or we should just move on.
I would just say that, like, to this question's point and to what Dave was saying, there is this valence and arousal curve due to the limitations of existing sensors and the fact that we're just starting to understand the brain and other types of sensors and understanding users and implementing those at scale. There is a lot of assumptions, at least with facial graphing or eye tracking, where they do put a one-to-one mapping between an emotion and a category. It just provides a lot of false positives and people could lie, right? And maybe that's not a bad thing, at least for this first step, right? Like if you, you don't want people sometimes to think that you're feeling sad when you're at an event, right? And that might be true with the technology we're working with right now. And so I think that right now we do have these kinds of limitations. And with time, through personalization, through long-term data studies, through, for example, and long-term, I don't just mean like multiple people over, extended periods of time. I mean the same person over an extended period of time. And we're just starting to get those types of sensors. The very first one was a Fitbit, right? But now we're going to have devices like, like N10, right? You put it on your head, you're wearing it all day, you're working, etc. And through this, we can start to crack these nuts. But at this point, that is a limitation of the field.
So I want to go back to Simi. You talked a little bit about when I asked you about how are you approaching design, and you talked about jobs to be done and empathy mapping, which are traditional experience design tools, right? I'm curious if you guys are using anything outside of that. I would think that a lot of prototyping, like prototype first.
So is your question around the different processes, or like?
Yeah, it has, with all this data being collected, our design processes changing. I understand, like at a certain part, like where you're starting out, empathy mapping and traditional UX tools are really valuable, but at some point, like when you get into prototyping and actual testing your ideas, like, does anything change? Has anything changed in the way you see design being approached?
Absolutely. I think one key part of that equation in terms of like prototyping and testing is building hypotheses before you go in, right? And so we've been doing some like assumptions mapping exercises together as a team to bring in like designers and engineers and researchers in the same room to kind of think about a problem, understand it from different perspectives, and jot down a few hypotheses that we think think to be true. And so our cycle there looks like, hypothesize, design, test, learn. And that's the cycle that we continue. We take the data from there, and then we hypothesize, design, test, learn. I think it's great to learn by building as well. So, we make decisions internally to go ahead and, just hit the ground running and build something and put it in the hands of users and see how it works. And sometimes it ends up being the right thing, which is cool. But I think it's like finding the balance between like what to go ahead and build and what to focus on prototyping, and how those things kind of relate to users in different contexts. So I'd say that like assumptions mapping is an exercise that we found great value in. Does that answer your question?
I think so. I mean, I think that for myself, when dealing with the new technology, spending a lot of time ideating over personas and whatnot, rather than just like building something and like see how it works. I'm more inclined to just, like build a prototype and put it in the hands of people and to see how they respond, rather than spending a lot of upfront time trying to design and be analytical about the design process.
Absolutely.
Yeah. So I was just curious about that. Ramses, I'm curious, do you have anything to say about the design process in terms of your interaction design?
Yeah, I mean, like I said earlier, it all comes back to this design space. There's no rules written, right? And I think that when there is no rules written at this point in time, it's very easy to make mistakes or to create. And, imagine the very first graphical user interface. Imagine the first time that you put together a website or a document and you wanted people to fill something out. One of the maturity steps is understanding that less is more. And there's companies that have built their entire reputations off of this. For example, Apple, they basically strip a lot of features from what they do to make it simple. And so that's what I would say from my perspective, which is there's still so much more maturity to be done in the area, in the space. We're setting the rules, but it doesn't mean that we have to forget what has already been learned in UX and UI when it comes to user interactions.
I think one thing that's been important also for us is to solve certain moments of like friction when it comes to designing like user interaction, right? So if you think of like the IoT use case, like we're becoming more and more dependent on the internet and like remaining online, which means like a downed connection, for example, can lead to devices failing to respond. Or doing so with some sort of delay. And I think that's a huge hit to user experience, and those moments should be accounted for every single time. So like in UX, you press a button and you see a result, and in IoT, where remote controls are like king, you need a way to make the user feel satisfied by like notifying them somehow that their remote interaction has, bore some kind of fruit. I think like losing connection, for example, failing silently, I think leaving users guessing in the dark is a big no-no. And it comes down to like, how do you elegantly communicate moments of friction to the user? And I think one really cool example is this project that we built out called Coco VR. Magnopus actually won an Emmy Award for this in 2018. It's actually a companion piece to the Coco movie by Pixar about the Day of the Dead. And it's essentially this like rich interactive, like multiplayer experience where you embody these like artsy skeletons. So you're in a space, you're with your friends or your colleagues, and when someone loses connection, you see the skeleton like fall apart, and you see a pile of like bones on the floor with a little like icon on top of it that says lost connection. And then when the player comes back online, the skeleton builds itself back up and you see the player in the space again. Like, how delightful is that, right? I think that elegantly communicating moments of friction to the user like that is also really, really valuable.
Cool. I think I'll share a quick story that kind of bounces off of that, because I thought that was like really, really cool to hear. So when we first did our virtual reality demo where people could grab objects and throw them using brain activity, there was a moment in time where somebody would focus on an object and consciously want it, and then it would come to them. And then after their experience, they'd be like, okay, so how did I do that? It didn't make sense. Like, how do I trigger it? And it's weird whenever like you don't think about wanting something and then it happening. Usually in your world, you watch your hand move and grab something, or you watch your hand move and click a button. And that's how you see the action. But when your brain is involved, it doesn't necessarily have to go through that physicality for an action to actually happen. And so we had to, and while in the future, I think that we won't have to add feedback. What we did in the virtual reality systems, we actually added feedback to the system. We added little lights to help individuals. We made them a lot brighter than they actually needed to be. We helped let them understand how to focus on objects, or we had them even practice how to focus on an object to really understand how their brain can be involved in the process of clicking. And what's really interesting is even though the most natural form is just wanting, because that doesn't exist in this world in a tangible way, we had to artificially create it. And so it teaches you how like the future is going to be a completely new form of creating interactions. And we're actually going to have to guide people into letting go of their need for physical feedback for some of the things that they do.
Wow, that's really interesting to think about.
And I'll give kind of just one more sentence. Voice
Sure,
is such a good explanation of that. Like, do you know all the commands you can send to your device? Right? How many do you actually use? Right? Very little. And it's because the absence of an interface and the fact that you can just ask or want, that unknowing, the fact that there's no interface there is like just such a empty void for you to feel, right? And imagine doing that with a brain computer interface, right? So I think we have to drop the little cookie crumbs to get people to feel comfortable. And I think voice even needs to do it now. I think that there needs to be more integration on like, hey, this is the type of stuff that you can do, but make it organic. Because right now it's like, hey, these are the 5 things that you can do. Okay, remember them next time. Cool, bye, right? But I think there's so much more that we can tap into if we really start to understand how to teach invisible interfaces to people.
So I know that Microsoft, even though they have the voice command, they have a lot of visual cues to go along with that. So we're wrapping up. There's time for maybe one last question or comment from the panelists. What's the future that you see? If we haven't already, in a lot of ways it's been covered, but what are you most excited about?
I'll go first real quick because I do have to hop off like 7 minutes ago.
Okay.
But the future that I see is a future where your glasses, your phone, your phone is inside your pocket, you're wearing glasses, you're wearing AR contact lenses, you're wearing AirPods or headphones, and those are your compute devices. That's how you interact, connect with the entire world. And so if you believe that too, feel free to join our Discord, join our conversations. Love to have you there. Support us on Indiegogo. Help us build this future.
Awesome. Thank you so much, Ramses. Elias?
I agree 100%, Ramses, with what you just said. Yes, the VR is going to be probably replacing so many devices that we have today, right? That's the direction it's going. And the future is bright for VR, definitely.
Mm-hmm.
And thank you for inviting me.
Absolutely. Thank you for coming. It's been really great. Dave, you're next on my screen.
Sure. The future is, like the others totally nailed it. I mean, it's basically that the data that you are interested in finds you and finds ways of displaying itself to you on the surfaces around you, the smart devices that you're wearing or that are in your body or that are on the surfaces. So it just becomes, instead of data being located on a particular device or display, it just kind of becomes part of the ether. Yeah, I'm excited for that. And I'm excited for the promise of like a more multi-sensory future where vision is not so cluttered and dominated and people are staring at screens, but they can lift their heads and interact with the world. And yes, thank you for having me. This was a fascinating conversation, and I can't wait to continue it with you all. So find me on LinkedIn or go to Haptics Industry Forum if you're in the haptics industry or you aspire to be, and we can keep talking.
Sounds great. Simi?
+1 to everything Dave said. And I'm also excited about the evolution of smart spaces and, being able to access them digitally, remotely, in real time. And to be able to share those experiences with other people simultaneously. I'm also looking forward to technologies that are able to anticipate our needs. I think there are a lot of like aha moments that I had in this conversation about the possibilities. But yeah, and to be able to do so safely, I guess safety is also a really important component here. So yeah, and if you want to reach me, guys, you can find me on LinkedIn at Simi Shinoy. Shoot me a note. Be happy to connect.
Okay, everybody. Thank you so much. Ray, do you want to close us out?
Yeah, definitely. Thanks for coming out. Like, our next event is in July, where we're going to be talking about the future of art and NFTs and all these other kind of hotbed terms that are going on right now. I look forward to see kind of the state of these things as it relates 2 months from now. And yeah, keep an eye out. We'll synthesize all the different kind of links and things like that were posted in the chat, and we'll send them out in our thank you email. And yeah, keep an eye out. We've recorded this video, and so we'll eventually put it up on YouTube as well, so you can go back and look at it again. All right, we'll see you next time.